All right, good morning. So we're looking at days 7 and 8 in your packet, which is on page 17. There's one problem here that's worked out for you. The other one I will walk through with you. This is just putting everything together that we've learned about rational functions and their graphs and what we can get from equations. So really here, nothing is new for today. It's just really putting it all together, making sure you have it all down. So this problem here is worked out. It is very important to, before you start figuring out what we know about rational functions from our equations, it's really important to put them in factored form, okay? And reason is because if the numerator and denominator have a common factor, that actually adds in another characteristic to rational functions, which we aren't covering, and you'll see that in pre-calculus, but you just want to always get in that habit. And it also helps you because it sets you up to see your vertical asymptotes. X equals 4, x equals -1, right? So if it's factored, it's a lot easier to see those. Same with your zeros. If you look at your numerator here, x squared plus 9 doesn't factor. And if you did try solving that by setting it equal to 0, you would get x squared equals -9. Well, if we take the square root of a negative, we don't get a real number. So what does that tell us? It means that it doesn't cross our x-axis. So since we can't do that because of the negative, that's why that's a none. So just something to think about, and that's why we have that box there. Obviously, in every different situation, any test question, any of this, it might not say factor at first, or if you see something on the SAT, ACT, college placement exam in a few years or next year, they might not say factor at first. It might, just be asking you, what's our vertical asymptote? You have to know to look at your denominator and set it equal to 0, okay? So that's all there, okay? Graph is there, all that. So let's walk through number 2 together. So again, goal is to factor this. So this is also kind of nice because it's giving us a review from our factoring unit. So notice here you have a sum of cubes. So that's going to factor down to x plus 1 times x squared minus x plus 1. And then in the denominator, you can factor out a 3x first, and you're left with x squared minus 9. And then that x squared minus 9 factors as well. So that's where we get the x minus 3x plus 3. Okay, this is what I was talking about. At this point, you would look to see if you had common factors to cancel. You're not going to see that for this problem. So we would continue on. Our horizontal asymptote, remember, is the ratio of your leading coefficients of the same degree. So notice here, you have 1x cubed divided by 3x cubed, and that leaves you with y equals 1/3. So next step is to put that dotted line at about 1/3. Okay, just do the best you can. And remember, what does a horizontal asymptote tell us? It tells us what's happening as x gets really big and as x gets really small. So what we know right now is our end behavior just from our horizontal asymptote. What happens as you work down the left side of the number line? Your function approaches, actually I should say f of x approaches 1/3. And as x gets really big, f of x approaches 1/3 again. Vertical asymptotes are next, and we all know where those come from. Those come from our denominator. So when you set that equal to 0, when you set that equal to 0, and when you set that equal to 0. Okay, and the reason those are vertical asymptotes is because you can't divide by 0. So if any of those are true, that means the function is undefined. And we have what looks like this here. Now, right now you see two types of asymptotes. You see vertical and horizontal. You cannot pass or cross the graph cannot cross the vertical asymptote, okay? Because no matter what, your function will never get an output when you plug in 3, -3, or 0, because your denominator will always be undefined. Horizontal asymptotes can be crossed. So that blue line can be crossed. It is not always. You have to remember, what is it there for? It's telling us what's happening at the ends, okay? Vertical asymptotes give us our domain. So we're going to go from -infinity to -3, -3 to 0, 0 to 3, and 3 to infinity. Okay, so notice how we have these written. Vertical asymptotes give us our domain. Horizontal asymptotes gives us our end behavior. X-intercepts come from the zeros of our numerator. So that means if you were to set x plus 1 equal to 0 and solve, that gives us -1. And if you set x squared minus x plus 1 equal to 0 and solve, you're not going to get anything from that, okay? So it's just going to be the only 0 you'll get is from this one, okay, because this never happens. Y-intercept, we plug in 0 for x, we get 1 over 0, which is undefined, so it's a none, so that means it never crosses. How do we know it doesn't cross? Because it cannot cross that vertical asymptote anyways. Other points. Now, the reason that we have that is kind of to fill in the rest of our graph. So right now we know we have an x-intercept at -1. Okay, we really don't know what's happening in between -3 and 0. We don't know what's happening from 0 to 3. We don't know what's happening from 3 to infinity, or from to the left of -3. So at this point, you want to plug in some values. Like, let's say you want to plug in a value over here. So that could be like a -4. You'd want to plug in a value in here. Actually, let's try not doing that and see what happens. And then we could draw in, or pick a point between 0 and 3. So let's say 1. And then we could pick a point greater than 3, so let's say +4, okay? And you're just going to plug those in and evaluate them to see, because what we're looking for is, are these points, and is the function like above that horizontal asymptote or below? We know that the signs change, you know, as we reach a vertical asymptote. It can change from the left side to the right side, or at an x-intercept. So that's kind of our goal here, is to figure out what this looks like. So at this point, pause this and evaluate at -4, 1, and +4. Okay, so as you plugged in some values like -4, 1, 4, you got those points. But you can see it in that middle between -3 and +3. It's kind of hard to tell what's going on, especially if you're looking on the graphing calculator, at least the one I was looking at. So I threw it into Desmos to kind of see what it looked like, and this way I could also put a screenshot. So something with rational functions, they don't always follow the same exact pattern, okay? A lot of them do. Obviously, the parts to the left of -4 or -3 and the part to the right of +3, that's a very common look to these rationals. But this, when you zoom in, you can see what's happening between -3 and 0, and 0 and +3. So this definitely gives you a better picture to fill in the rest of your graph. Okay, so what we do know, though, is that between 0 and 3, it can't be crossing again, because another x-intercept would have shown up in the problem. So now, where is this function greater than 0? It is greater than 0, let's see, from -infinity, so that first lane. If you look at this as like lane 1, lane 2, lane 3, lane 4, it's separated by the asymptotes. Lane 1, it's always a greater than 0, okay? So -infinity to -3. And then in lane 2, it does a little bit of both. So it starts to go above 0 at the x-intercept, which is -1. Lane 3, it's never above 0. Lane 4, it's always above 0. Okay? Then where is it below? So in lane 2, it is partially below. So from -3 to the x-intercept. And then it's below the entire lane 3, which is 0 to +3. Where does the function change signs? It changes signs at asymptotes. So notice it's positive to negative at -3. does the same thing at 0, so it goes from positive to negative. And same thing at 3, except it goes from negative to positive. And then it also changes sign at your x-intercept, which we can clearly see is right here. So that would be at x equals 1. Okay, so that's kind of the putting it all together. Everything that I just went through, nothing was new. Hopefully, if anything, it's just kind of making more sense of it, seeing how it tells us everything about it. So the next page, it says summary of the graph. What I want you to do is kind of go through what do you do when you look at a rational function and you're being asked to graph it? How do you approach it? Okay, what's step 1? Step 1, factor it. So go ahead and write out your steps on this back page. Pause it, check back in, see if we have the same. Okay, so here's our steps. First one, factor it. Okay, factor the numerator and denominator, cancel if needed. Again, that'll be a topic in pre-calculus next year where you'll have that happen. 2, find the horizontal asymptote. So remember how we do that? You're kind of going back to the pre-factored function first to see that. But graph and determine your end behavior. Find the vertical asymptote. Graph and determine domain. So remember how to find the vertical asymptote. Set your denominator equal to 0. Next, find your x-intercepts and graph. Those happen when your numerator is 0. Find your y-intercepts and graph, or what? There's only going to be one, if there is any. Remember, you just plug in 0 for x and simplify. And then you got to fill in the rest. So if you, like that last problem, we had 3 vertical asymptotes. It created 4 lanes. You may need to find 4 points to determine where the functions are. Like each piece, okay? So if there's only 2 lanes, because you only have 1 vertical asymptote, a point to the left and a point to the right is all you need. If you already know that from your x-intercept or from your y-intercept, you may not need to find any others, okay? So think about that too as you're doing these. If you're graphing, and let's say you have a vertical asymptote here, you have a y-intercept there, you have an x-intercept there, and you have, let's say, a horizontal asymptote here. You really only have one option of how to graph this, okay? Because what's important about asymptotes, it's telling you as you get closer to them, your function tries to touch them, but never does, right? And then this, obviously, must be below as well, okay? Could these go up and then come back down? Sure. Same thing over here. And so that's why it's important. You guys have your calculators. You can look at it. But so just something to think about. If you have if you have only 2 lanes here, because you only have 1 vertical asymptote. So here's lane 1, here's lane 2, and you have already a point in each lane. You probably don't need any other points in order to graph this. Okay. So next, as you look forward to next week, we'll be continuing with this on Monday, reviewing Tuesday, Wednesday, and Quest will be on Thursday. Okay, so please make sure you're checking into Canvas daily and looking for the activity or the review, whatnot, to get us ready for Thursday. Okay, have a good weekend.